So far we've built the oscillator, video basics, borders, ball counters, ball motion controls, bricks, ball and play counter, and serve logic on sheet 1, the paddle logic and on-screen display on sheet 2, the start game controls and operational latch on sheet 3, and the flip screen circuit on sheet 4. Today we'll add the scoring logic from sheet 2. If you're following along, we'll be using the RevFX schematics today, not because of any inconsistencies this time, but simply because I rearranged the logic a bit for better flow. You can find high-res images of both the original RevF schematics and the updated RevFX schematics in GitHub. In part 1, we discussed some chip challenges, and one of the topics was replacing 9000 series with 7400 series. For the 9310 decade counters, we're using 74160s, which are pin compatible, and you often find 160s in legacy boards. We're also replacing a 9602 dual one-shots with 74123s, and this is one instance where the parts are not pin compatible, but also not 100% logically equivalent. There are slight timing differences for the LS parts, but that's not really material here as they're mostly used for gating sounds and you wouldn't notice a difference. For the triggering input, however, the 9602s use an OR gate while the 123s use an AND. This is not really an issue because all instances in Breakout only use one input and tie the other. We just need to make sure we tie the unused inputs to the correct level. The problem here is a difference in the clear logic. On 9602s, the clear input is independent, but on 123s, the clear also ties into the trigger. So if conditions are right, deasserting the clear line will trigger the one-shot. We'll need to see if this condition affects any of these and then figure out a way to suppress any undesired triggering. Alright, let's wire this up. We'll need a new 74160 decade counter in Nancy 6, Mary 6, Love 6, Henry 6, Jack 6, and King 6. A new 7408 in Nancy 7, a new 74123 in Nancy 8, and a new 74192 in Nancy 9. We'll also be using 2 gates from chips we already installed, and we'll need some passives. We'll start with this circuit, which determines the points per brick and feeds the player's score counters. First, we'll need to swap out that 9602 and adjust the tie. You can see that this one shot is held in reset while in attract mode, and it gets triggered when you hit a brick. You'll also notice that this is missing the typical timing capacitor. This basically uses whatever parasitic capacitance is laying around to generate a short output pulse. Probably just a few picofarads giving a 10 to 20 nanosecond pulse. It does feel a little strange that they used a one-shot here when the brick hit signal is already pretty short. Maybe just using up a spare gate? Don't know. Anyway, when you hit a brick, this points per brick counter is loaded with a value that depends on horizontal signals, so let's map it out. It's easier to look at this with 16 Henry and 8 Henry already inverted, and the combination of these signals creates 4 distinct lanes with 2 rows each. Since the high order bit is tied down and the low order bit is tied up, the possible load values are 1, 3, 5, and 7, depending on which row pair you hit. After load, the counter value is higher than 0, bringing up the borrow output. This gates S clock to the DN pin, stepping the counter down until it reaches 0. This turns off borrow and blocks S clock. These same countdown pulses are gated to the player up's score counters, and this center inverter here drives the brick hit sound mechanism, which we'll cover in the next video. You can also see that the counter gets reset to 0 on game start. I'm not sure if this is necessary because the counter quickly self-drains anyway, but we'll leave that in. Also note that since this is used as a down counter and is only loaded to a maximum of 7, we could use a 74193 here instead. Both chips behave exactly the same in this setup, so we don't really need to buy and stock this one-off part type when a 193 will do. These lines feed the player score counter, so let's go there next. The top set keeps track of player 2's score, and the bottom set tracks player 1. As usual, the clocks for each set are tied together, and the TC outputs and CET inputs are wired for cascaded stepping. 160s are decade counters, so TC will rise when the value hits 9, allowing the upstream counter to step at the rise of the next clock. The CEP inputs provide a secondary enable depending on the player up. I'm thinking these could simply be tied up because the count pulses are already segregated by player, but we'll just leave that alone. Counter outputs are drawn backwards by bit weight, and each group feeds the funnel for a single digit in the on-screen display. You see the standard ABCD notation for the ones digit, and they simply extend this nomenclature for the tens and 100s. You probably noticed in the last video that the bricks for player 1 and 2 were the same because we didn't have this line yet and just tied it down. In the bricks video, we discussed that set bricks gates 2 Henry to the RAM player 1 line during game start so that the brick arrays for both players get set. Today we can finally attach this and have our 2 separate arrays. Let's turn this on and take a look. Reset. Start a new game. And right away we've got 2 problems. The score rolls as soon as the ball appears, and everything we hit is worth 9 points. Since we're not looking for an easy mode, we'll need to fix this. I checked to make sure all the wiring was okay, then hooked up the logic analyzer. Basically hooked up everything in this section. The attract line, the start game line, also added trigger A for reference even though it's grounded. Added the brick hit on trigger B, the inverted one-shot output or not load line, the borrow out, the down clock, then the input and output lines. This software shows both the individual lines and the rolled up hex value of those lines, but it would be nice to allow you to hide the individual ones to save space. Let's see why we're getting 9s for everything first. I'll trigger on the inverted one-shot output, start a capture, hit a brick, and got it. You see the brick hit line rise, triggering the one-shot and dropping the output. The load input value here is a 1, which is what we would expect hitting a brick in the first row. The output should therefore go to a value of 1 right after load drops, within 40 nanoseconds according to the datasheet. We do have a 1 here, but it's 140 nanoseconds out. We also see borrow out rise, but it's way out there at over 300 nanoseconds, when it should be 24 or so. Then without any provocation, the output turns into a 9, about 80 nanoseconds after BO rises. Nothing here is kosher except for that it does count down. Even then, BO drops really late after the output reaches 0. I captured a few more hits. Here the input is 3, but the output still does that 1 to 9 dance. Same thing with what should be a 5 and a 7. I don't have any different brand of 192, so let me pop in a 193 instead. Capture that. Here you can see that on load, the 1 shows up in the output and the BO line goes high quickly at about 25 nanoseconds. Well within spec. And she counts down from 1 to 0, then BO drops blocking S clock. Nice. Here's a capture of a proper 3, a 5, and a 7. Looks like I picked up some more winners from eBay, and just like the 7448s in the last video, the 192s are no longer available from major suppliers. That's probably why I went trolling in the first place. I'll order some different 192s to test, but for now let's leave that 193 in there. The counter still rolls when the ball appears, however, so let's take a closer look at that one shot. The not attract line is hooked to clear, which is fine because we want to suppress counting while the ball is rattling around in attract mode. From the game state video, we know that the not attract line rises just after you press one of the start game buttons. But in order for the rise of attract to trigger the one shot, the brick hit signal must also be high, which doesn't make any sense since we haven't hit anything. You can see here that brick hit drops, but not until after you press serve and the ball appears. I had to go back to part 10, where we went over the game state logic to remember the timing. When we start a new game, the start game lines assert, which turns on the set bricks latch and forces on brick hit to write 1s to the RAM. This cycling continues until the player presses the serve button for the first time during a game, and the ball initially crosses into the near field area. This turns off serve wait, which turns off the set bricks latch, dropping the brick hit signal. The timing issue here is that attract mode turns off first while brick hit is still on, and as soon as brick hit drops, triggers the one shot. To me, this is not supposed to happen, but here it is. So we need to figure out a way to either keep this one shot from triggering in this scenario or suppress the one shot's output or suppress counting. There are a few ways to do this, but my preference is to make as little change to the original design as possible. We do have this other trigger input we can abuse, and after looking at all the available signals, the best thing I can think of is to hook it to an inverted copy of this net, or what I call the can hit brick line. If you remember from part 9, this latch is reset when you hit a brick and gets set only when you hit the back wall or paddle. This permits just a single brick hit at a time. Since this latch is held in reset by not brick hit during RAM initialization and doesn't get set until the ball hits the paddle, we can use it to suppress triggering when the system comes out of brick fill cycling. If we stuff the inverted version of this signal into the A input of our one shot, it will only allow the brick hit signal through when we're ready for it in all cases. We have a spare gate here that we can use as an inverter, or we could feed the inverted brick hit signal into A and the regular can hit brick signal into B. I'll use the inverter in the breadboard since brick hit is already hooked up, and we can decide which way we should go later. This is the only logical change we've had to make to use modern chips, so I think this is okay, quite minor, and we don't have much choice. Let's test that out. No extraneous points when the ball initially crosses into the near field, and the rest of the scoring works properly. While I was working on those fixes, some other 192s came in, and I have to tell you, I've never seen such innovative packaging for integrated circuits. Pop one of those in there. It works like a charm. And you know what to do with the fake ones. A quick test to check we have 2 separate brick arrays. Start a 2-player game. Hit a few bricks. Second player's wall is fresh. Hit a few there. Switch back to player 1. Looks like that's all working fine. Let's throw today's work into our retro schematic. Add the parts. I made my own symbol for the 123s to properly show the triggering inputs. Add nets. Wire everything up. And rename everything. Probably should have done that earlier. Well, we're gaining on it. I thought that was going to be a really easy session, but we ran into a few snags. You don't really learn too much without problems, and we've had our share. In the next video, we'll make some noise. Thanks for watching.